My name is Emmett Stiff, and I am a new business development manager for Regal Rexnord. Regal Rexnord is a manufacturer of conveying components, conveying solutions, and powertrain solutions. And I'm happy to be here today to speak to you about conveyor technologies and robotic palletizing strategies through the lens of an automated warehouse 10 years in the future. We're going to look at what will be true of warehousing, distribution, intralogistics, and end-of-line manufacturing today and a decade from now. So to summarize the presentation, what are we going to talk about today? Well, a brief introduction. In the unit package handling space, efficiency and uptime are key. So what is the unit package handling space? We're talking about material handling, and my role in the material handling industry is from the point of view of conveying networks and conveying solutions. So that's how I look at it in an automated warehouse. Now, regardless of what you do, efficiency and uptime are key, and this is a never-ending quest for us, trying to reach maximum efficiency and maximum uptime. We're going to explore some of the challenges that affect businesses today, 10 years from now, and then we're going to dive into some of the key emerging technologies that we actually see here presented today at PAC Expo and understand how they're really going to make an impact over the coming decade to rethink how we implement conveying strategies in an automated warehouse. So we'll go over some of these emerging technologies, and then near the end of the presentation, we're going to focus in on two emerging types of warehouses. Those that handle high volume package amounts, and those that require high precision package handling requirements. I assure you, it's going to be an interesting ride. When I was asked to present here at PAC Expo on the innovation stage, I really struggled to think, what would people want to learn about? What would people want to hear? And I turned to Jeff Bezos, founder of Amazon, for some inspiration. And it was interesting uncovering this story about Jeff and a question that he was often posed, which was, what's going to change in 10 years' time? And while he appreciated that question, he didn't really like it. And he thought, the more interesting question is, what's not going to change in 10 years' time? Because Jeff believed that what wasn't going to change in 10 years' time was something you could build a sound and stable business strategy around. So what won't change in 10 years' time? And if we think about Amazon, well, Jeff knew that even back in 1998, that customers would always want three things. They would always want the cheapest price for whatever it was that they needed or wanted. His customers would always want a vast selection, everything from A to Z. And that's why in the Amazon logo, you see the smile that reaches from the A to the Z. And lastly, he knew that his customers would always want fast delivery. They placed the order today, and they'd want their item as soon as possible. So that's what Jeff did. He took those three key elements, things that he believed would never change, and built the Amazon business around those. So taking that inspiration and thinking about the automated warehouse, the automated distribution center of the future, what can we suppose that won't change? But before we go into a specific industry of automated warehousing in DCs, what's not going to change for all businesses in the next 10 years? I like to think of these as the mega challenges that all of us are going to face over the next decade. So challenge number one, demographics are destiny. And on the screen, you can see we have a population pyramid showing how the population has changed in North America from 1950 through to today and on to 2050. And to summarize what is happening here, it shows that on the whole, the population is getting older. And when population gets older, it leaves less room for people to do low value added manual tasks. So the point is, as the population gets older, there'll be less available labor for manual repetitive tasks, and therefore these tasks will be automated. Second, the big challenge of climate change. We can see that the planet is getting warmer around us, and as a result, we are getting more and more powerful weather events. Things like derechos, hurricanes, tornadoes, and these mega powerful events really have an impact on our electricity system. How many of us are prepared to go without power for a week, let alone a day, with our dependence on all our electrical devices? So not only is the electricity system at risk from these powerful weather events, but the demand for electricity is also set to skyrocket in the next decade, primarily due to the fact of artificial intelligence and the need for power of these data centers to manage the AI workload. So we're going to have a choice to make. Who's going to be kept cool first? Us or the data centers? And it's interesting to note with these new AI chips, they require such intense cooling systems to help support the workload. So not only are we going to have to deliver ways of providing more power, we're going to have to become more energy efficient. We really have no choice in the matter. And that's something that a lot of us in North America are not really accustomed to. Other parts of the world, such as Europe, have been focused on energy efficiency for longer than we have. But I do believe over the course of the next decade, energy efficiency was going to take center stage. So for all of us operating motors in our conveyor networks in our facilities, we're really going to have to look at electricity availability and electricity reliability. And lastly, scalability. As we've seen over the last couple years, especially with the pandemic, things can change on a dime. And all of a sudden, our businesses, our customer demands can be turned on their head. Whether it's from pandemics or from a change in government, whether from packaging requirements, consumer preferences, or environmental regulations, all this causes us to have to manage a change in business. So we need to be able to scale, and we probably need to be modular as well so we can tack on components to our operations to ensure that we meet either increasing demand or remove equipment so that we can meet decreasing demand. Because the number one goal is to ensure we are operating our machinery all the time, because down machinery is a wasted cost. And this impacts the financial metric of return on total capital employed. So the three big things facing all businesses: demographics, climate change, and the ability to adapt to changing economic conditions. So that's the big global piece facing all businesses. Now let's dive into what is going to remain true for those of us material handling engineers, operators, and the automated warehouse space. What is going to remain true for us today and in 10 years' time? We know that our equipment is going to require flexibility. Flexibility in terms of handling a wide range of packages, sizes, types, weights, whether it's corrugated cartons, poly bags, paper mailers, whether they weigh 1 pound or 50 pounds. Your material handling equipment is going to have to handle the entire gambit, because you really don't know what your customers are going to request of you next year, 2 years from now. Second, accuracy. What happens in an automated warehouse? Packages are brought in, they are sorted, they are stored, then they are retrieved and sent out for customer delivery. We all know how upsetting it is to have a package lost in the mail, to be expecting an item to be delivered to our doorstep this morning, only to find out, sorry, it's been lost, it's going to arrive tomorrow. Maybe we don't even know where it is. So accuracy, the ability to sort to the right location 100% of the time. Operators in this space are going to require that today and in 10 years' time. And lastly, the options to adjust to change. As I mentioned, change requirements can come from anywhere. So you have to be ready to meet that challenge. And if you're operating a material handling network, that really does come down to being able to scale quickly and to be able to add components and retract components quickly, just like if it was a Lego set. So we've seen flexibility, accuracy, options change will be required today and 10 years from now. So let's look at some of the technologies that are emerging today, specifically here at Pack Expo. As you walk around the show, you're going to see a lot of this type of equipment on the floor, and you know that in 10 years' time, it's going to be present in your operations. So we have robotic arms. We have humanoid robots. We have complex conveyor networks spanning many levels. They incorporate omnidirectional roller belt technology to move packages left to right and deliver them to the right locations. We have autonomous guided vehicles or automated mobile robots, commonly known as AGVs and AMRs, that bring items to people, commonly known as goods to person. We're seeing the emergence of drones. We have electric vehicles that have self-driving capabilities. And myself, being here in Chicago for the show, seeing the new Amazon delivery vehicles roaming the streets that have electric drivetrain technology. Wow, the future is now. And lastly, we will still have ourselves, manual laborers, working in a warehouse, but we know that these workers will be digitally connected using sensors, using a laptop, using augmented reality to quickly diagnose problems, mechanical problems, machinery issues, and quickly solve them. You know, with so much of these technologies, it's a lot for one person to master. So the wired worker will have a ton of information available to them so they can fix problems that they weren't trained for. So a wide range of technologies emerging today, and we can be sure that they will be commonplace in the warehouse of the future. Me working in the material handling sector, conveyor networks, I wanted to highlight a couple of specific technologies that are really impacting my job and the messages that I bring to material handling engineers and automated warehouse operators. So the first big breakthrough I want to quickly discuss are vision systems. Now, if you think 10 years ago, if you wanted to take a nice picture, you'd probably need a very expensive SLR camera. You'd need a memory card that was quite large. You'd probably need a subscription to a software program like Adobe Lightroom, Photoshop to manipulate that image to make it look as you want it to, magazine quality. And what do we do today? We pull out our iPhone, we select a filter, and we hit the button. Job done. So vision systems like those found on our phones are becoming tremendously advanced. They see the world in ways that we don't see it. They can see heat, they can see infrared, they can see on the infrared spectrum, they can see in the dark, they can recognize packages, and then when you combine this technology with AI, they really have a good handle on every package that is inducted into the warehouse. Second, motors. Motors are becoming more energy efficient and smarter. And we are seeing, when it comes to conveyor networks, the idea that instead of having one long, big conveyor belt, you segmentize the conveyor belt into smaller individual modules that are driven by motorized drive rollers, commonly known as MDRs. And an MDR is where you take the motor and the gearbox itself and you internalize it to the roller. And these MDRs are low voltage motors, 24 volt, 48 volt. So they're highly efficient. And the nice thing about having a conveyor system that works in small modules is you only need to turn on the section that actually has a package on it. Whereas traditionally, we'd have one big long belted transfer conveyor, and that would run at the same speed with the same power draw, whether there was one package on there or 100 packages. Sometimes, though, you do need those big transfer conveyors that are driving one big long belt. And so we've got the advent of new IE5, International Efficiency Rated 5, permanent magnet, ultra premium motors that are 40% more efficient than IE3 premium motors. You can see when these IE5 motors are operating that they're quite cool to the touch compared to an IE3 motor. And so when you have a lot of heat being generated, you know that is wasted energy. So IE5 motors are becoming more prevalent, and that helps support the need to be more energy efficient. Lastly, an industry I wouldn't call it a breakthrough per se, but a thought process that is really being adopted. And that thought process of being modular, being scalable, adopting those themes right from the conception stage. Why do we do that? Well, because we never know what the business condition of tomorrow is going to be, so we need to be prepared to adapt. I like to use the analogy of a bathtub in a bathroom renovation. So let's say you put in a bathtub that's twice the size of your current bathtub. But if you don't change the faucet and you don't change the drain, then it's just going to take twice as long to fill that bathtub and twice as long to drain it. So what have you really done? You've just moved the bottleneck to somewhere else in your system. So to be truly scalable, to be truly modular, you really have to have a holistic view of your system and design it so that, if I upgrade or I improve the efficiency of one part of my system, I'm not just moving the problem further down the stream. So we spend a lot more time in design and conception. We have tools like the digital twin, where we can virtually operate a warehouse and we can change the parameters to see what the impacts are on not only the equipment, but also on the ability to manage our throughput. So vision systems, motors, whether motorized drive rollers or super premium permanent magnet motors, and thought process around scalability and modularity are key emerging technologies that are going to have an impact on the warehouse of the future. And for you material handling engineers and warehouse operators, you need to be conscious of this from the get-go. So we've covered the global impacts facing all businesses. We've looked at what's true of automated warehouse operators, DC operators today and 10 years from now, which is the need for the equipment to be flexible, to be accurate, and to be able to adjust to change. And given that, we're now going to look at what we see as the two distinct types of automated warehouses that are going to be prevalent in the future. So the first type is a high accuracy, low precision warehouse, which is commonly featured in e-commerce and intralogistics. And the other will be a high accuracy, but more importantly, high precision automated warehouse that is synonymous with end-of-line automation and robotics. So why did I draw the distinction between accuracy and precision? Well, first we need to understand the difference between accuracy and precision and how they relate to one another. So on the right side of the screen here, we've got a target set up. And most of us, when we see these kind of targets, we think of maybe the pistol shooting at the Olympics this past summer, or we think of Robin Hood and his bow and arrow. And intuitively, we know that what we want to do is put the arrow in the center of the target. And if we're really good at our job, we put that arrow in the bullseye over and over and over again. That repetitive ability to put the arrow in the bullseye over and over again means you're highly accurate and you're highly precise. Now, to the left of that, we've got a situation where we're accurate in the sense that we're getting all our arrows on the target, but we're not precise because those arrows are scattered across the target. Now think of the target as a chute for which you're trying to put a package. In the e-commerce and intralogistics example, you can see I've got a sort lane, and packages move down the center of the aisle and they're diverted left or right depending predominantly on the zip code that package has to make its way to. You can see that the chute is relatively large compared to the expected size of the package. So I don't have to make sure I'm diverting right from the center of the blue sort conveyor. I can be sometimes a little before it, I can be sometimes a little after dead center, and still get the package into the right location. So this type of high accuracy, low precision is featured in e-commerce, whether it's retail apparel or it's a firm like Amazon, and Amazon is the example that I'm trying to draw out here. And in these facilities, we can usually get a throughput rate in terms of sortation between 2,500 packages an hour and 5,000 packages an hour. Now, the other type of automated warehouse, which is where we need high accuracy but high precision. And why do we need that? Because we've got robots in there, and robots don't think, robots are programmed, and so if that package is not where the robot expects it to be, you're going to get a missort, or you're going to get the robot to tip the box over, and then a human manual labor is going to have to come and reset the operation. So you sacrifice your throughput with being precise, and that's just the fact of life. So let's dive a bit more into the high accuracy warehouse, where accuracy is crucial. So accuracy is crucial. How do we ensure that we're being accurate? Well, let us use material handling equipment that can handle a wide range of package types and sizes, because we know that that package has to end up in the right location. And with these type of firms, such as in e-commerce, they're focused on the speed to the customer. As well, if you're in retail apparel companies such as Lululemon or Aritzia or Arc'teryx, where they're very expensive jackets, you know that your customer is going to be concerned about the unboxing experience when they receive that package at home. So it's important to use equipment that is gentle on packages. On the other side, intralogistics, yes, they are high accuracy, low precision type of warehouses, and they focus on just processing that package as quickly as possible, so less concerned with the unboxing experience. Summarize, your material handling equipment needs to be able to handle a wide range of packages and ensure it gets to the right location 100% of the time. So how do we volumize accuracy? What are the strategies we can incorporate into an automated warehouse such that we can strive to reach that 100% uptime, that 100% accuracy? Well, we're seeing firms incorporate omnidirectional roller belt technology And the advantage that this technology brings is that the ability to sort is enabled across the entire length of the conveyor module. So if you look in this photo, you'll see a divert and transfer module with a big, long orange roller. And what this technology enables you to do compared to, say, a pusher arm that might be focused on just pushing a package from the middle of the conveyor, this omnidirectional roll belt technology allows you to sort across the entire length. And when you increase your sort accuracy, you increase your throughput. Also, with newer technologies that eliminate the need for compressed air. Compressed air is you need to take a motor, you need to drive a compressor, you need to push air into a tank, and that air inevitably leaks. So you have to run that compressor numerous times a day just to recoup that lost air. So by using technology where the divert mechanism is powered with electricity, you're actually only needing to use the electricity required to move the package and not to compress an air tank. And lastly, omnidirectional roll belt technology, these compact modules allow you to tack on multiple sort locations as your automated warehouse expands in size. So who has done really well at this? Well, we got to say that Amazon is a great example of leveraging new technologies to really boost their accuracy and boost their throughput. And today, Amazon delivers 1.6 million packages a day in the United States, and that number is growing. And my experience and my recommendation to material handling engineers and operators in this space is that if your customer, your client, comes to you and says, look, I need equipment, I'm going to be changing my package types because of consumer preference or because of environmental requirements with respect to packaging and waste, then you have to turn around to your vendors and say, look, I need equipment that can handle a wide range of package types as well. Sure, it may cost a little bit more money, but in the long run, if your equipment can run more often and handle more types of packages, you're probably going to find more clients and you're going to be operating more consistently, which will bring in more money and improve your return on investment. And secondly, we've seen in facilities like Amazon where they are processing a lot of packages a day, high throughputs can result in big mechanical overhauls. So you want equipment that is easily accessible and easily serviceable. Don't want to have a complex machine where it could be very difficult to access the internals or be very difficult to find spare parts. So those are my best practices and success stories for a high volume type of warehouse, such as those in e-commerce and online apparel retail. And now we're going to look a bit more into the other type of automated warehouse that focuses on end-of-line automation and increasingly robotic palletizing. So here, precision is crucial. And why is that? Because, as I said, the robots don't think for themselves. The robots are programmed to pick a package from a precise location. So you better make sure that package is where it's supposed to be. And if it's not, you're going to get a mishit. So we see a lot of these palletizing lines that are coming onto the market. They do try and handle a wide range of carton and case sizes. And from an intuitive point of view, when I talk about why precision is important, you think of these robots that are being used in the automotive industry, where they're picking up a 2,000-pound car frame and swinging it around. Well, if that robot is not precise in where it's placing that car frame, let's say it's off by an inch, it could hit another piece of equipment and significantly damage it. So precision is crucial when it comes to incorporating robotics. So what are some of the strategies we can incorporate to volumize precision? So again, talked a bit about vision systems. It doesn't see like we do. So one of the interesting things that I found with vision systems is that they really rely on depth perception to help segmentize packages. So if you've got a bunch of bags or a bunch of boxes on a belt, the robot is always trying to figure out, okay, where does this package end and where does the next one start? So firms have been incorporating omnidirectional roller belt technology where you have spheres or rollers on equal pitches, and it creates a textured belt. So compared to a traditional fabric belt, you've got a textured belt, and it helps the vision system segmentize those packages. And when you're able to segmentize more quickly, more efficiently, you actually help the robot make a successful pick. Also, we're seeing firms incorporate systems with the motorized drive rollers because these are low voltage motors. And when you combine them with photo eyes, it does give you real-time feedback on where your package is positioned on that conveyor belt, where the alternative technology has been using these external geared motors driven by a VFD. And because a VFD is really just an electrical frequency going into a motor to operate the speed at which the shaft rotates, you need another device to help confirm that the shaft is in the correct position, and those are called encoders. So by moving to MDRs combined with photo eyes, you're eliminating the need for VFDs and encoders, which can be a significant cost savings. And lastly, with the advent of omnidirectional rollerball technology, where we divert packages basically from underneath, it's very gentle. So you eliminate the need for maybe costly pusher arm assemblies, which require servo motors and big overhead gantries that have big steel frames. So you eliminate that material and you've got a more cost-effective, more reliable sortation solution. So strategies to volumize precision, what we've seen in the industry is, again, using this newer emerging omnidirectional rollerball technology to help position cases and cartons on a conveying line so that the robotic arm doesn't have to reach as far. And when the robotic arm doesn't have to reach as far to make a pick, you're reducing the cycle time of the robot, and that actually increases the throughput of your system. You can also use this omnidirectional rollerball technology to totally redesign how a palletizing system is set up. So palletizing systems in the past have been centered around a human doing that manual process. But when you start thinking, okay, I'm going to incorporate robots, well, you want to maximize. You can't have humans near the robots, so you need to, make sure you have a area that is quite contained, fenced off, so that it's safe. And you want to be able to bring packages quickly to that robot in the correct position, so it doesn't have to think and reach further than it needs to. And lastly, managing process is harder than managing people. So we see in our business, people want to bring in automation, but they get frustrated if they spend a lot of money and they don't increase their throughput, they don't increase their sort accuracy, and they say, well, why is this happening? And often we find that you need to start at the very beginning with your manual process and understand exactly everything that goes in to performing that process correctly, understanding the time component, understanding exactly where the package has to move. And you create a performance indicator, a KPI. So when you understand exactly what it costs and what it takes to do the manual process, then when you bring in your automated solution, you have an apples to apples comparison that you can make. And then you can really understand, okay, this is what my return on investment is. So those are a couple And again, this success story often Robotic is a firm that I showed earlier in the presentation. They have really taken the lead on redesigning their automated warehouse of the future, and they're incorporating omnidirectional roller belt technology. And I think we'll see a lot more of them and their success over the coming decade. So I want to thank you for joining us today. We looked at, what are the key requirements in the material handling space from a conveying systems point of view. The need to be flexible, the need to be accurate, the need to be the capability to adjust to change. That is needed today. That will still be needed in 10 years' time. Push your vendors to give you the equipment that you need in order to ensure you have those capabilities over the long run.